Alright, here we are, brand new chapter. And what we're going to do is we're going to start with an x and y coordinate. Do you remember that stuff? Actually, unfortunately. Well, you could look at it as a new opportunity. I would look at it like that, wouldn't you? Say, maybe I didn't really get it before, but now here's one more chance, and I might be able to get this stuff. That's how I would look at it. Right? Glass half full, kind of idea, right? Optimist. Yeah, I try to be an optimist. I really do. I'd much rather live my life optimistically, wouldn't you, than pessimistically? I would. Yeah. Yeah, I'm not always optimistic, but I like to try to be. All right, here we go. So I've got an x and y coordinate. Which one is the x? Do you remember which one the x is? That's the horizontal, and then the y is the vertical. So that's not hard. So far so good, right? And you know about the points, right? What is this point right here where they intersect? That's the origin. It is 0, 0. Okay? And, of course, to get a point over here, how would I get to that point? I would go in the x direction, then I'd go in the y direction. What do I call that thing right there? This parentheses with a comma in between x first, then y. What do I call that? Well, it is a coordinate. Very good. I could call that a coordinate. But when I have this whole setup with parentheses and an x first and a y second, I call it an, what is it? Ordered pair. And you're right, Jared, it is a coordinate, okay? It's where it's located, all right? So if that went over like 5 and this went up 3, then this point right here would be 5, 3. That's the coordinate of that point, and it's written as an ordered pair. Everybody hear what I just said? Okay, we call that the coordinate of this point, and it's written as an ordered pair. Ordered because it has to go in a certain order. You go in the x direction first, and then you go in the y direction. This is all coming back, right? You had this in Algebra 1, Geometry, Algebra 2. So this is like the 4th year just in high school that you've seen this stuff, at least. All right? That's starting off pretty easy. Let's do this. What if... let's see what I'm going to do. Let's get rid of these. Let's make some more points in here. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we'll go down here 5. Okay. So what I'm going to do is I'm going to put a couple points here. Let's do this in a different color. Let's put a point, and I don't have any specific place where I want to put them. I'm just making these points up. So let's put a point right here, and let's put a point right here. Okay? What I'm going to ask you is to find the distance from one point to the other. All right? Find the distance. So what does that mean, find the distance? Well, we're going to take from this point, we're going to draw a straight line down to the other point. And we're going to find the length of that line. That's what we're trying to do. Okay? I'm not going to go through all the explanation that I would for maybe an Algebra 1 class or Algebra 2 class or even a Geometry class. But I will do this. Watch. If I wanted to find this distance from here to here, can I just count? Can I say, oh, that looks like 1, 2, 3, 4, 5, 6. Can I do that? No, that wouldn't be very accurate at all, would it? Okay, so what I'm going to do is I'm going to, let's do some different color. I'm going to make...
Rise over run.
Okay, well, it's kind of rise over run. Because I'm trying to find the distance. Oops, what did I do that for? Might not be perfectly straight, but I want it to go like this. It's kind of rise over run, but I'm finding the actual lengths. Right, so what I want to do is this. I want to go from this point, and I want to find the length of this yellow line right here. Then I want to find the length of this yellow line right here. Now, if this is vertical and this is horizontal, that means that's a right angle right there. So how in the world is knowing this vertical line and this horizontal line, how is that going to help me find this blue one right here? What can I do? What if I found this distance? What if I knew this distance from here to here, and I knew this distance from here to here? What would I use to find the blue one? Pythagorean theorem, exactly right. Do you remember that? Okay, and what is Pythagorean theorem?
A squared plus B squared equals C.
Yeah, it's as easy as ABC, right? That's how I like to say it. All right, you just have to remember a couple extra things in here. Now the C is always what of this right triangle? This is always the hypotenuse of the right triangle. Okay, and the A and the B, what do we call that of our right triangle? The legs of the right triangle. Okay, so the A and the B are always the legs, and the C, the one that's by itself, the one that's not being added to the other stuff, is always the hypotenuse. Everybody got that? So if I wanted to find this length right here, let's actually figure out what this ordered pair is. What's this point right here? Well, let's just count over. 1, 2, right? We went 2 on the x, and how far up do we go? 1, 2, 3, 4, 4, right? So 2, 4. That's the coordinate of that point right there. What about this point down here? Let's find that. Well, we go on the x first, so we go 1, 2, 3. We went to the left, which is what? Negative. So we went negative 3, and then you went down 1, which is negative 1. So that's the coordinate of that point. Everybody with me so far? Okay, and if I wanted to find the length of the blue, that's what I'm trying to find. Now, to go vertical and go horizontal, it's actually kind of easy to figure out, right? So what could I do to find that length? I could just count, couldn't I? All right, I could count. Let's just do that. So if we start here, we're actually, watch, we're starting at where? 4, right? And are going down to what? Negative 1, aren't I? We could just count if we wanted to. 1, 2, 3, 4, 5. Right? So the length of that is 5. Or you could, what could you do with the numbers? Look, I'm here at 4 and I'm here at negative 1. How can you get a 5 out of that? Do we add them up? We subtract. That's right. 4 minus negative 1 is 5, isn't it? So what if we didn't have the picture in front of us and all I had was that number and this number? How would I find the length of the y? I would subtract those, wouldn't I? I would go 4 minus negative 1. And I'm getting somewhere with this. Okay? I'm not just saying this just in a random manner. Okay, I'm trying to point something out to you. That's right. I'm not going off on a tangent. A math term. So watch. 4 minus negative 1. And what is 4 minus negative 1? It's 5, isn't it? Now, it doesn't really matter when you're doing distance that it's negative 5 or positive 5. Because what am I going to do with those legs anyway? I'm going to square them. And if I square a negative 5 and if I square a positive 5, I still get the same exact thing, don't I? So it doesn't really matter if I make this negative or positive. I'm just looking for the length, looking for the distance from here to here, okay? What about from here to here? I could just count over, couldn't I? Okay, but what is this point? This point is 2, right? Now, I'm counting over the x direction, aren't I? So look at my x numbers. I got a 2 here, and I got a what? Negative 3 right here, don't I? So what is, oh, this, shoot, I didn't mean to draw it like this, but that's right. It works anyway. 2, what's 2 minus negative 3? 2 minus negative 3. It's positive 5, isn't it? 2 minus negative plus plus, right? So that's a positive 5 as well. So that length right there is also positive 5, isn't it? If I would have thought about this, I wouldn't have made it the same just to make it a little different. But it's all right. It still works. You with me on that? So how did I find the length of the y's? I just subtracted the y values. How did I find the length of the x, the horizontal one? I subtracted the x values. Everybody see that? All right, again, I'm getting somewhere with this. Now, I got to put this in Pythagorean theorem, don't I? So what's the blue? The blue, what letter? It's the C, isn't it? So I'll put a big C right here. What's this 5 right here? That's the A. And what's this 5 right here? That one's the B, right? Now, this isn't always going to be the same number. You understand that, right? All right. So, so let's put the numbers in. So what do I got? You could write a squared plus b squared equals c squared, but I tell you what, I usually do this. I write c squared first. Is that all right? C squared equals a squared. So what's my a? It's 5. It's 5 squared. Yeah, we'll put 25 in a second. I just want to make sure we know where we get that 25 from. Plus b, what's b? 5, and then we square that. Now, what do I do to get that squared out of there? Because I want to solve for c, don't I? So how do I get rid of that squared? Square root both sides, right? So if you want to look at it, it would be c equals the square root. Everybody see that? Because I'm getting rid of this. And then what is this? 5 squared is 25. And this 5 squared is also 25. So c is equal to the square root of what? 50. 25 plus 25 is 50. Right? What in the world was Tiffany saying?
5 square root of 2, because when you factor out 50, you get 25 and 2.
Right.
25 can be square root of 5.
Right.
And 2, I can't square root that any further without getting an ugly decimal.
You got it. Okay, and that would be your simplified answer right here. Okay, 5 squared of 2, because we simplified this radical right here. And she said it exactly right. Couldn't have said it better myself. All right? And that's the length of this thing right here. Now, if you wanted to, you could always put that into a calculator, I guess. And let's do that. We could put the square root of 50 if you wanted to. Oops, let's clear this. Put square root first. Square root of 50. And that's 7.07. Or let's just say 7.1. So what's the length of this blue line right here? It's about what? 7.1. Kind of blends in there, but this would be an exact answer, and this right here would be an approximate answer. All right. It depends on how they say it. I think if I read off the answers to these, I believe I'll be reading off the exact answers. Okay. But in real life, if you're going to do something, if you're a carpenter and you wanted to find the length, right, of the piece that connects these two, and you've got a right angle here, you know, you wouldn't use 5 square to 2, right? You don't have a ruler that says 5 square to 2, do you? But you do have a ruler that says 7, right? And if you have centimeters or metric system, you could always go 7.1, and that'd be very easy to find. So in the real life, sure, you would make it 7.1, but if I want an exact answer, it would be 5 squared to 2. Okay? All right, with all that said, now we know how we got that. How did we get this 5? Well, we subtracted the x values from each other, didn't we? Right here, we went 2 minus negative 3, correct? See? 2 minus negative 3. That was the x. X is always first, right? So 2 minus negative 3 is 5. That's how we got that 5. How did we get this 5 right here? Well, I subtracted the what? The y's from each other. 4 minus negative 1. 4 minus negative 1 is also a 5, right? Then what did we do with those? Well, we squared them, right? We squared this first 5 and we squared the second 5. And then what did we do to get c by itself? We took the square root, okay? It was all Pythagorean theorem, wasn't it? Now I'm going to show you the distance formula, and you're probably used to seeing the distance formula, but what I just basically showed you right here is how we get to the distance formula. Right? And I'm just going to show it right out right here. It's a little different than I normally explain it, but I think this will work fine. If I wanted to find the distance between those 2 points, that's kind of like the C in the Pythagorean theorem, isn't it? But why did I make it a D and not a C? Because D stands for what? For distance, right. So I put D for distance, okay? So D for distance. Now what did I do? I took the square root, right? Isn't that what I did right here? Took the square root. How did I get this? Well, I subtracted the x, right, and then I squared it. So look at this. What am I going to do here? I'm going to subtract the 2 x's. And how do I show the 2 x's? Do I just go x minus x? No.
x1 minus x.
Right, I go x1 minus x2. So I take the 2 x's, and it doesn't matter which order it's in. Now, some books will say x2 minus x1. It doesn't make any difference. I just subtracted x's from each other. That's it. And then what do I do to it, though? What did I do to this after I subtracted the x's from each other? Well, no, not yet. I did what to it? I squared it, right? I had to square it because I'm putting in Pythagorean theorem, so I need to put a little squared right here. You see where this is coming from? It's all coming from the Pythagorean theorem. That's what the distance formula basically is the Pythagorean theorem. Now, what did I do to get this 25 right here? What did I do to get the other 5? I subtracted the what? The y's from each other. Okay, so I go y1 minus y2. And then what did I do to that after I subtracted the y's? I squared it, so I square that. And then how did I get c by itself? I square rooted it, didn't I? So this just shows the distance by itself. So I put a big old square root, and that right there is our distance formula. Write that down. Distance formula.
Make sure the x1 next to a subscript's not exponent.
Yeah, they're not exponents. It just means the first x and the second x, okay? It's not x squared and x to the first, okay? They are subscripts, okay, underneath here. It just means take the first x and take the second x, subtract it from each other, and square them. That's all it is. Does that make sense? All right. Let's do a little example here, since now we know the distance formula. You have that distance formula written down now, so let's do an example. And I'll give you a chance to do this yourself. Give you a couple minutes. Here's 2 points. We called the first one point P, and it's negative 8, 4. And then we called the second point Q, and that's 3, negative 2. All right? So find the distance between those 2 points. Now, do you have to graph it like we did on that? No, you don't have to graph it, okay? You now have a distance formula, right? And we figured out how we got that distance formula. So find the distance between P and Q. All right, I'll give you a second to work on that. All right, that should be enough time. Let's, if you still didn't finish, just kind of follow along what we do here. Let's go a different color. Let's go this purple. All right, so it says find the distance between these 2 points. Well, let's write down the distance formula. What I would do every single time you have to find the distance, I would write down the distance formula, okay, just like we said. So remember, it starts with a square root, and then it's Pythagorean theorem, isn't it? So what I like to do is this. I call this like the shell of my formula, okay? It's all the stuff before I put stuff in there, right? It's the outside of it. All right, so what did we do? What did we do to get the A and the B right in our Pythagorean theorem? Well, how did I get this? I subtracted what? I subtracted the x's, didn't I? Then how did I get this number right here? I subtracted the y's. It's really not that hard. A lot of people look at this and it looks real confusing because you got squareds, parentheses, you got these subscripts, you got the big square root, and it looks like crazy. But it's really not that hard if you understand where it comes from. Okay, it comes from the Pythagorean theorem. So distance formula looks very, very close to the Pythagorean theorem. So let's put some numbers in here then. It says x1 minus x2. So you got to know which one the x's are. Which ones are the x's? The first one, right. This one right here and this one right here. Those are my x's. And so what do I do to those x's? Just subtract them, okay? And it doesn't matter what order you subtract them in. It doesn't matter if it's the first one minus the second one or the second one minus the first one. It doesn't make any difference. All right, let's just go the first one minus the second one. I just like to stay consistent. Makes it easy for me, so I do things the same way every time. So I just subtracted those. And then I do the same thing with the y's. So let's take a look at the y's. Put these in a box. Those are my y's right there, and I subtract those. What do I get? 4 minus negative 2. If you have a negative here, don't forget to put minus negative. All right, it's very important. It's not just 4 minus 2. All right, let's do this. This is, put a big square root there again. This is negative 11, isn't it? But we're going to square it. And this is what? That's 6, and we're going to square that thing. All right. Negative 11 squared. Well, when I square a negative, remember we talked about this earlier? If I square a negative, it comes out positive anyway, so I don't even care if it came out negative or not. What's 11 squared? 121, right? You in your head. What's 6 squared? 36. And what is that? That's 157. And I tell you what, I think we can just probably keep it like that. Do you? I don't think that simplifies. Nope. Yeah, I don't think it simplifies. So you just keep it the square root of 157. There's no reason to change that to a decimal. Everybody listening to me? Still got people trying to do that on tests and quizzes and stuff, okay? And I tell you all the time, you don't have to change this to a decimal. You can keep it like that. There's no problem just keeping it like this. All right? Now, does it make a lot of sense to you? Maybe not, what the square root of 157 is. But as far as an answer for this, you can keep it like that. We good? All right. It wasn't so hard, was it? Pretty easy stuff. It's good to know how we got to that. All right, now let me show you something else that you may think has absolutely nothing to do with the length of a line or anything like that. We're actually going to talk about a circle right here. So how in the world does a circle enter into the conversation? We're trying to find the distance between 2 points. Well, I'm glad you asked that question. Or did you ask that question? You didn't ask that question? I thought you did. All right, look at this. I'm going to put a circle here. And I'm gonna scooch this over so that, see the center of the circle? I'm gonna put it right at the origin. That's pretty close right there. Okay, so I got a nice circle right here. What I'm actually gonna do is I'm gonna come up with the equation of a circle. You know about equation of a line, don't you? Remember y equals mx plus b? All right. Well, a circle has an equation as well. And let's make the circle a different color just so it doesn't blend in. We'll make it yellow. Does that stand out enough? Tell you what, let's make it blue. There we go, it's better. What we want to do is we want to find the equation of this circle. And I want to show you how it has to do with a straight line. Watch this. Basically, the definition of a circle is this. If I start from the center of the circle, which is right here, because I put it right at the origin, didn't I? Okay. And if I went, let's go to right there. See that length right there? What do I call that length? It's the radius of the circle, isn't it? Okay, and it hits a point right here, doesn't it?
Could be any point.
Okay, it could be any point on here because the radius would be the same distance, wouldn't it? No matter what point on the circle that it hits, okay, this radius would be the same exact distance. Well, the equation of a circle basically is relating the length of this radius. All right, so I'll show you what I'm talking about. Let's do this red. What I'm going to do is I'm going to make it kind of look like what we've been talking about. Right? I'm going to drop this straight down, perpendicular, and I'm going to take this over. All right. And what kind of a triangle do I have here? I have a right triangle. Okay, as long as that's vertical and that's horizontal, then I have a right triangle right here. Now let's take a look at this. This point right here is just some point on the circle, isn't it? And we'll call it x, y. All right. Everybody with me so far? Okay. So what we're going to do is we're going to try to relate all this stuff and come up with a little equation. And let's see what we do here. Kind of looks, well, it doesn't kind of look like, it is a right triangle, isn't it? So I could go a squared plus b squared equals c squared, couldn't I? All right. What would this point right here be? Let's see if we know what this point is. What's this point right here? That's 0, 0. Okay. And what would this point right here be? We went over how far?
X.
X, right. Because look, if this point is x, y, how did we get to this point? We went over x and we went up y, right? So how long is this little bit right here? It's x, isn't it? Now how far up did we go to get to that point? We went 0, didn't we? Everybody see that? Okay. Actually, you know what? I don't want to confuse you any more than I have already. We don't even need that point now that I think about it. We could do this, though. We already know the distance formula, because I was trying to backtrack a little bit. But I think we already know the distance formula, so what we're going to do is we're going to put this into the distance formula. Okay? So instead of calling the yellow one d for distance, we already called it something. What is it? It's r, isn't it? For the radius of the circle. So instead of saying d equals the square root, what can we say? R equals, right? And then, because that's our distance, correct? Equals the square root of what? Well, let's do this. So how do we find what goes in here? What do? We subtract the x's, don't we? So what are our x's? X minus what? 0, right? And what are our y's? We subtract our y's. This is going to be y minus what? 0. Everybody see that? That basically right there, basically, is the equation of a circle. Now we're going to clean it up just a little bit, but that's basically the equation of a circle. But we're going to do a couple things here. What was this 0 and this 0? This was the center of the circle, wasn't it? Now, does the center of the circle always have to be at the origin? No, not necessarily. Look, this center of the circle could have been like way over here, right? And that would have been the center of the circle right there. So it wouldn't be x minus 0. It would be x minus whatever the x part of that point is. Do you see that? And instead of y minus 0, it would be y minus wherever the y part of that point is. So the circle doesn't always have to be in the center. Sometimes it is, and that's what it would look like. What would it look like if it was some unknown center? And they give this a letter. They call this H and K. I don't know why, they just do. So they call the center of a circle HK. So let's rewrite the equation of a circle. And instead of writing this square root, that kind of looks a little ugly, it kind of gets in the way sometimes. Let's just make this r squared. Is that all right? So that we don't have to see that big ugly square root. And that's just what they do most of the time. They usually make this r squared instead of making a big old square root here. So watch this. We're almost there. So r squared is equal to, now, how did we get to here? Watch, if I had a, oops. Right? If that was the radius of the circle right here, and this was x and this was y, what did I subtract? I went x minus what? X minus h, right? And then what did I do to the y? I went y minus k. That right there is the best form for an equation of a line. Okay? R is the radius. Okay, so R is the radius, and H and K was the what of the circle? It's not always the origin, okay, because it doesn't always, it's not always going to be at 0, 0. Could be anywhere else, couldn't it? So this is the center of the circle. Right, if it doesn't touch the origin, if the center isn't right at the origin, then H and K could be some other number, right? Now, in this one, what if H and K was 0? It would just be x squared and y squared, wouldn't it? Okay? So let me just show you. Now, that seems like it might be a little bit complicated, but to actually do the equation of a circle stuff, it's actually pretty easy. Watch this. Here's a question they might give you. They might say, okay, write the equation of a circle if the radius is 3 and the center, we'll just make something up, is negative 5, 1. All right? Write the equation of the circle. Well, here's the equation of a circle right here. What does it say to do? It says to take R and do what to it? Square it. So what is the R in this situation? Yeah, it's 3, and then it's squared, which is 9. Everybody see that? See where we got that 9? Okay, and then we put in equals, and then we do this stuff. Now, we just put x minus whatever the h is. What's the h? That's right. That's the h, isn't it? So it's minus a negative 5, which will eventually be what? Plus 5. Good. And what do we do with that? We square it. Plus, and then how do we do the next part? It's y minus k, or, I'm sorry, put a k right here. So it's y minus what? 1. And then we square that. Okay, that goes to plus, and that right there is the equation of that circle. Okay? That's how you write it, just like that. Now, you might want to clean it up. Some people like to write it like this. They'd like to put the radius on the right-hand side, but it doesn't make any difference, right? A lot of people might like to write it like this instead, because they like the x and the y on the left-hand side. It doesn't really make any difference, okay? And that's fine just like that. Either way is perfectly fine with. And what does that tell you? Just by looking at this equation right there, I can tell you exactly what the radius of that circle is, and I can also tell you where the center of that circle is located. Okay? Let's go the other way. Watch this. What if I said that what if I gave you the equation of a circle? I gave you this thing right here, and I told you to give me a couple things about it. Tell me what the center of the circle is, and also tell me what the radius of that circle is. What do you think, Tim?
Negative 7, 3.
Good. The radius, right? Is that what you're saying? Yep, the radius. I'm sorry, I lied. Center. What am I thinking? I know, I usually go the other way around. I know, I just messed up. So the center of the circle is what? Negative 7, 3. Why negative 7?
Because that's a positive and...
Because it's x minus what? Negative 7, isn't it? Okay, that's where people get confused a lot. But it's x minus negative 7, so the x part is negative 7. And this is just y minus 3, so 3 is part of the center. All you have to do is look at it, isn't it? Okay, figure out what the center was. What about the radius? Is the radius 16? Now remember, the radius is r squared. If r squared is 16, what's r? It's 4. And that's it. Pretty easy, isn't it? So if they give it to you as an equation of a circle, okay, all written out real pretty like this, you can find the center and the radius very nicely. Now, of course, we're in college algebra, right? Not just algebra. So you know they're going to get a little more difficult with this, all right? And that's probably what we'll do. We'll probably settle in this tomorrow a little bit, and they may not always give you the equation of a circle nice and pretty like this. Sometimes they give it to you, and you got to manipulate and change things around a little bit, and that's what we're going to talk about tomorrow. What I'm going to do is I'm going to give you a worksheet. Now, you're not going to be able to do every one of these. In fact, let me just write down which ones you're going to be able to do. You should be able to do 1 and 2. And you should be able to do 7 and 8. That's it. Okay?
Please report to the office. Brooke Arbridge,
the rest of them
Aaron
we'll do
Fogarty,
tomorrow, okay?
Keith Harden.
Or at least we'll try to do it
Thank you.
tomorrow.